Hello and welcome back. Today we will look a little bit on where we can sense planet Earth and get the first ideas of what we might want to measure at particular places. When we think of the Earth, we can categorize and group it into regions and themes according to certain properties. Most commonly, those regions are referred to as spheres, although they are not spheres in a mathematical sense. Generally speaking, we can list 5 of these spheres, and they are the Geosphere or solid Earth, the Hydrosphere, the Biosphere, the Atmosphere, and the Cryosphere. As you can see, these names were taken from ancient Greek, summarizing the most dominant feature of a certain domain. But let's look at them one by one. Sometimes the term Geosphere is used in a wider sense that includes almost the whole planet. However, in modern books and papers, as well as in this course, we define the Geosphere as the sphere on which you're standing on. Which means that it is also including the whole inside of the Earth. We will later simply say solid Earth, as this is a more accurate and less ambiguous than the term Geosphere. The name solid Earth is attributed to the idea that the inside and surface of the Earth consists mainly of solid, rocky material. However, strictly speaking, also magma and other liquid materials inside our planet are assigned to the solid Earth. As we normally can't look inside our planet, we are somewhat restricted to what is called the Earth's crust. We will see later, when we discuss about solid Earth, that there are methods and techniques to figure out how the Earth is built up inside, so stay tuned for more on that. The second sphere, called the Hydrosphere, is kind of completing the Geosphere. Hydro is the Greek word for water, and this sphere includes all the zones on our planet where we find water. Oceans, rivers and lakes are the most obvious features one would call Hydrosphere. However, the term hydrosphere covers all mass of water found on, under and over the surface of our planet. This means groundwater, soil moisture and water in the air need to be taken into account as well for what is called the water cycle of the hydrosphere. But water is not just water. We have to distinguish between salt water and fresh water. Knowing that oceans cover a large fraction of the surface of our planet, it is not a surprise that salt water accounts for 97.5% of the water on our planet. Fresh water, on the other side, accounts only for 2.5%. Also, we need to know that more than 2/3 of fresh water is in frozen form, for example ice or permanent snow cover in the Arctic, Antarctic and other mountainous regions. We will refer to frozen water as the Cryosphere, which we will discuss in a minute. In general, we know that only 30% of all fresh water is not frozen and exists as groundwater. To make things even worse, only a small fraction, actually less than 0.3% of all the fresh water on planet Earth is easily accessible. As fresh water is important for us humans, we need to monitor and predict where we have access to it and how this access might change over the years. The Cryosphere is somewhat connected to the Hydrosphere as it deals with water as well, but only in its frozen form as ice or snow. It includes all the frozen parts of the Earth. The glaciers, icebergs at the sea, the huge ice caps in Greenland and Antarctica. As we had just learned, 2/3 of the fresh water on our planet exist in frozen form. Therefore, it is very important that we know where ice caps or glaciers are melting and disappearing. We need to know where the water goes once it has melted and whether it comes back. The Biosphere is maybe the sphere where most things are going on when it comes to us humans and animals, flowers, plants, etc. In general, we can say that the Biosphere includes all living things. The trees in large rainforests, as well as those in your garden, birds, insects, but even viruses and other tiny living organisms. And of course, it includes all animals, and not to forget ourselves, humans. In particular, forests play a large role in the biosphere, as their existence ensures that air contains just the right mix of elements so that we can breathe. Therefore, it is not a surprise that forests are often also called the green lungs. We will see later how important it is that we measure and document deforestation in order to preserve this vital environment for the next generations. The last of the 5 spheres is the atmosphere, and it basically describes the location of air that surrounds the whole Earth. In order to have an atmosphere on a planet, it is important that there is gravity, which means that the planet has enough mass so that atoms and molecules in the air do not escape out into space. As for our planet, the atmosphere is mostly composed of nitrogen. But it also contains oxygen, which is very important for most organisms to breathe. On the other side, it also contains carbon dioxide, which is used by plants, algae and other organisms in order to conduct photosynthesis. Having an atmosphere is also crucial for a planet, as it protects us from solar ultraviolet radiation, solar wind and cosmic rays. In addition, winds, weather and other mechanisms strongly determine the look of landscapes and regulate the exchange of components from other systems, like the hydrosphere. Sometimes you will see different names, or people will talk about 4 spheres instead of 5. For example, the term lithosphere is sometimes used instead of geosphere. In this course, we will not follow this scheme, as it will conflict with the naming of zones inside our planet, as we will see in later lectures. Therefore, we will either use the term Geosphere or Solid Earth. Another discussion is that sometimes the spheres can't be really distinguished clearly. Sometimes people assign the Cryosphere to the Hydrosphere, as strictly speaking, the Cryosphere deals with frozen water. In the end, it is only a small distinction, but what we should be really aware of is that our planet is composed of different regimes which have very distinct properties. However, there is often a strong interaction among those spheres, and measuring those properties and processes is of utmost importance for understanding and predicting the complex system Earth. Thanks for watching, and see you next time when we learn more about what it means to sense planet Earth.